Right, for this question, there's a couple of ways you could probably do it. I'm going to do it diagrammatically, but what you're essentially trying to find is the probability of the bus being on time, or the complementary of the bus intersection with the complementary of the train being on time. The problem you've got here is that none of these events, as you found in the previous question, are independent. So probably the way I would have looked at this is actually looked at drawing a Venn diagram first. And the reason why is I want to find out what the probability of each of these individual items are. And as I said, there are many different ways you can do this. This is just the way that I do it to get it right in my head. So we'll draw our own little Venn diagram here. This time we've got two circles. So we've got the probability of the train, and we've got the probability of the bus being late. And we know that as a general rule, the whole probability of the train being late is equal to 0.25. Okay, and that the probability of the bus being late, B, is equal to 0.17. We also know that the probability of the intersection of B and trust being late is equal to 0.045. And that relates to this bit here. Okay, so that there is the intersection. Now, the probability of the train, on the other hand, being late, so this one here is 0.25. So what about the train only? So if you go 0.25 minus 0.045, you find out that the probability of the train only being late is 0.205. Okay, and if we do the same with the bus, we go 0.017 minus the intersection. We just want to find this area here. Now, this will become clear in a moment, but that is 0.125. So remembering that what we're trying to find is the probability of them both being on time, and that the part of the diagram that deals with that is all this area around the outside. Okay, all this area around the outside represents all of them being on time. So what we can do is we can say, therefore, that the probability of the bus being on time and the train being on time is equal to 1 minus, because remember 1 is the entire universe, the entire Venn diagram, minus the three parts that we've worked out. So 1 minus 0.125 minus 0.205 minus the intersection, which we know 0.045, and that tells us that the intersection, or sorry, not the area of that part of the graph, so the probability is 0.625. And that is the probability that both are on time.